Okay, for the last part of the day, we're going to end with a more complicated problem, and we're not going to actually take it all the way through. I would on a board in an actual classroom setting, and I was trying to do that with the slides, but it just filled the slide too much. I don't mean to scare you. It's actually not that bad. I think what's more effective for slides here is just to walk through an outline of what to do. And I think the whole point of showing this more complicated problem is less so related to expecting you to have to do a problem of this kind in the future. Again, once you see it, you're going to be fine. I could see a problem like this um, expected on a future exam or something like that. But I think the bigger point of doing the more complicated example is it clarifies even better the type of examples that we started the day's material with. That's all. Okay. So sometimes, you want to start less complicated, clearly, right, in some examples. But then once some less complicated examples are done, people get into this mode of like, well, what if and what if? And um, often it takes then after some examples are done, people are like, okay, I think it works like this, but to be really sure, you just kind of want the affirmation that on a much more complicated example, the problem runs exactly the way you think you do, exactly the way you think it does, and that is exactly what we're going to see here. Okay, so we've got w is equal to u plus v squared. We have u equals x squared y cubed, and v equals x to the fourth y to the fifth, x equals s to the fifth t to the sixth, and y equals s to the seventh t to the eighth. And we are asked to find dw dt. So it's like the first several parts of today's slides. It's just, so here's a start of an answer. This is just an outline, okay? But W, you'll see, depends on U and V. U and V both depend on X and Y. So you'll see the arrows from U to X and U to Y, V to X and V to Y. Now, X and Y, those formulas both depend on S and T. So you see arrows from X to S and T and arrows from Y to S and T as well, right? So that I hope that dependence diagram makes sense, even if what's more complicated is simply that it has grown one layer, right? This is just like a taller diagram than the diagrams that we've seen so far. It's just one extra layer taller or something like this. So now we just need all paths from W to T if we're finding dw dt. And the paths from W to T, if I'm not mistaken, are W to U to X to T, and that creates the first term, and then W to U to Y to T, that created this second term, and then W to V to X to T, that's this third term, and then W to V to Y to T, which is this fourth term. I hope I don't have any typos in this, and I believe those are the only four paths to get from W to T, and if you're good up to right there, I think you're going to be fine. You should now just try this on your own. I tried to just write the slide, and then I ended up commenting out what I put in. Here's the outline of the rest of what you need to do, right? Find all the partial derivatives that are requested up here: dw du, du dx, dx dt, and so on and so forth. And then do replace intermediate variables, but you're going to have to do this in stages. I would suggest you replace all the u's that you see then with x squared y cubed, and all the v's with x to the fourth y to the fifth, and replace all the x's with s to the fifth t to the sixth, and all the y's with s to the seventh t to the eighth.